Hi, welcome to Unit 10, Day 1 Notes. This is the beginning of trigonometry. So we're talking about angles and standard positions. We're going to talk about radians today. We're going to talk about degrees. So when I'm counting an angle, I'm starting at the x-axis. And when I'm counting counterclockwise, it's going to be a positive angle. Right? And when I'm counting negative direction, which is clockwise, for those of you who can tell a non-digital clock, that is going to be a negative angle, right? So when we're measuring angles, one revolution, like one whole circle, is 360 degrees, right? So in degrees, theta, you may see it as S, or you may remember as the measure of an angle in geometry we talk about, or your teacher probably talked about the M. Angle M is the measure of the angle, right? Theta. Radians isn't going to have this little degree symbol. It's going to be like in terms of pi, right? So that's S, and then your radius, or your radians. So we have R to go back and forth. So S, this is the arc extended, right? That's what S is right here, or it may be M when you're measuring it. Our conversion of angles, so to get from degrees out of radians, you're going to do 180 over pi. And to go from degrees to radian, you're going to do pi over 180. So today you're going to have to go back and forth between the two. Arc length is the measure, right? If we're talking about, oh come on. Measure of that arc on the circle given the angle. And you could just see it a second ago, the camera wanted to go crazy, right? So the measure of this arc length, right? So if we're talking about in terms of S, it's going to be R times radians, right? Your radius times your degree. Or if we're talking about degrees, it's going to be the M over 360 times 2 pi R, right? So you're talking about the fraction of the circle effectively. So you're going to need a fraction, right? When we're talking about the area of the sector, so you're talking about that piece of pizza right there. Same idea. It's going to be the fraction, your theta in radians or in degrees, and then it's going to be the area formula, so it's the fraction of that, gives you the area of that pizza, or you have the degrees over 360 times 2 pi r squared, right? So those are the formulas you're going to need to use, and no, you're not going to get them on the test, so you're going to need to remember them and be able to work with them, right? So 40 degrees, we are starting from the x-axis, we go counterclockwise, and this angle is 40 degrees. Right? Negative, I'm going to start at the x-axis. I'm going to work the other way to negative 135 degrees. Right? So 170 is positive, so I'm going to work this way to where 170 should be. And 330, I'm going to work all the way around to here, right? So negative, I'm going clockwise, positive, I'm going counterclockwise, right? You could maybe write them, I could call these other angles if I'm counting from the other way, but if they're measuring it, it should go the way, around the circle the correct way. So we're going from angles in degrees to radians. So the formula I'm going to need to use is pi over 180. So when I multiply, I'm going to have 300 over 180 pi. I can start to cancel my zeros. I have 30 over 18. Keep simplifying, so 5 pi thirds. Negative 45, I'm going to need to multiply times pi over 180. That gives me negative 45 over 180 pi. I can simplify. When I divide through, I end up with negative 1 over 4 pi. I can divide both of them by 45. Don't lose your negative along the way. Right? So to convert radians to degrees, I'm going to need to get rid of that pi, so that's why it's easy to remember my formula is going to be 180 over pi, because I need my pi's to cancel out. Right? I can keep going. I can divide by 6. I get 30 times negative 11, which gives me negative 330, right? Negative 330 degrees, right? Trying to get from radians to degrees, trying to get rid of my pi. So it's going to be 180 over pi is my formula. So 3 times 180 gives me 540 degrees. All right, this is if we are trying to find the missing information from the formulas. We have our radius is r, we have our central angle, we have our subtended arc, and A is area of the circular sector. Find the missing information, right? So if we have S equals r times theta, what do I know? I know my S is 3. I know my radians is 1/5. What I don't know is, I know my theta is 1/5. I don't know what my R is, right? So to solve for R, multiply both sides by 5 over 1. My radius equals 15 feet, right? Since I started with feet, I ended up with feet. All right, for B, I am looking for the area is 1/2 my radius squared times theta. Right? So what do they give us? They don't give us A. We are trying to find A. They give me my theta in degrees, right? So I have to get from theta in degrees to radians. So if we remember, if we look up here, how did I get from radians? How did I get, from degrees to radians? So I'm going to have to go 60. I need a pi for radians, so it's going to be pi over 180. So if I simplify, I end up with 1/3 pi, or pi thirds. So my R is still going to be 2. So I have 2 squared. And now I can take pi thirds and plug it into where my theta was. I'm going to multiply through. I get 2 squared is 4. 4 over 2 is 2. So I'm going to end up with 2 pi thirds meters squared. Right? So you could have done this, built, sorry, that was a whole lot of me talking and I forgot to move the paper up. So if you go back to A, this is where you get for your A. You have your arc, your radius, your angle theta. They don't give you your radius, solve for your radius. Over here, this is the formula we're looking for. We're trying to find our area. They give us our angle in radians, so we use our formula to get it 2 radians from degrees, plug it in, solve for our area. Right? Or we could do it all in one step if we take our degrees, right, and plug it in with our 1/2. Right, you still are going to end up with the same answer, 2 pi thirds meters squared. All right, go ahead, try your practice. Raise your hand if you have any questions.